This is my presentation on the Fibonacci sequence. As you can see, the Fibonacci sequence is a series of numbers as seen in the top right over here. The man who founded the Fibonacci sequence was Leonardo Fibonacci. He was known as Fibonacci or son of Fibonacci. He was born in Pisa, Italy around 1170 to 1175, and he died in Pisa around 1240 to 1250. He extensively traveled the Mediterranean coastline, meeting with a lot of merchants that were trading there and learning their arithmetic from their respective countries. The first origins of the Fibonacci sequence appeared in Indian mathematics with the Sanskrit Prasadi. It was a book with long enumerating patterns in it, and it's most clearly established in the work of Virahanka, an Indian mathematician. And then outside of India, it first appears in the Liber of Bacci. The Liber of Bacci was written by Fibonacci in 1202. It introduced Hindu and Arabic numerals, which were the digits 0 through 9, and their meaning of their place values to the European world. And it proposed a problem inside of it about the population growth of rabbits. And this population growth sequence would soon be known as the Fibonacci sequence. And then down in the book down here, you can see some of his work. So for the sequence, it's a series of numbers modernly started 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. And obviously there's a lot more, but that's how it starts. The formula is a of n equals a of n minus 1 plus a of n minus 2. And that's just the sequence. And you simply find a number by adding the previous two, as you can see on the bottom. And the numbers and the sequence give the solution to certain problems that I will discuss later. The Fibonacci uses, it's not just a useless sequence, it has some points to it. The Fibonacci spiral is used in Fibonacci tiling, as seen below. The spiral is created by drawing circular arcs connecting the opposite corners of the squares in Fibonacci tiling, using the square widths of 1 to 34. The tiling can be as big as possible, but in the thing below it's just 1 to 34. And it's also known as the golden spiral because it has the factor of phi, which is the Greek letter, and it's also known as the golden ratio. And the circular arcs of the golden spiral curl at this ratio. So more about the golden ratio. Phi, that symbol or the Greek letter phi, is approximately equal to 1.68, or more complete in 1 plus the square root of 5, and then all over 2. And then when it's stretched into a line, the longer part divided by the smaller part is equal to the whole length divided by the longer part, as you can see up here in this diagram. For example, if you have 61.8 divided by 38.2, which is the larger part divided by the smaller part, that'll equal 1.618. And then if you take the whole, which is 100, and then divide it by the longer part, which is 61.8, that will also equal 1.618. And then it's using the golden rectangle, which is once again pictured at the top right, where A would be a length of 1, and then A plus B would be a length of the golden ratio, which is how that rectangle was created. Pascal's triangle is not exactly related to Fibonacci sequence, but it takes part in that in a way. It was named after Blaise Pascal, a famous French mathematician, and it's used in a lot of different parts of math and has a lot of different properties to it. But the diagonals going left to right, if you add them, you get the Fibonacci numbers, as you can see in the diagram over here, which is the whole sequence. And if you would keep going, it would continue the sequence. Binet's formula was derived by Jacques-Philippe Marie Binet in 1843, and although the Greek philosopher Euler and a mathematician may have discovered it previously, it's the closed form solution of the Fibonacci sequence, which basically means that you can find the term, or the nth term, of the Fibonacci sequence by plugging it into the formula. Now some real world use is the Brock-Meerman growth model. It's an economic use of the Fibonacci sequence, and it was created in 1972. It was the first growth model with unpredictable shocks and takes into account uncertainties that will most likely happen, such as a stock market crash. And in the first part of the formula, the Fibonacci sequence is used to help write it. And the Fibonacci sequence also appears in nature. It appears in several biological settings, such as like branching and arrangements on the leaf of a stem. Flowers, like the yellow chamomile shown below, show an arrangement involving the numbers 21 and 13. If you follow their buds around, they follow those numbers. And another use is the bee ancestry code, which just mathematically shows how bees populate. It's a one pair, then two, then three, then five, which are all Fibonacci numbers, and they continue growing. Some fun facts about the Fibonacci sequence is that Fibonacci day is November 23rd because it has the digits 1, 1, 2, 3, which obviously start the Fibonacci sequence. Fibonacci himself helped popularize Arabic numbers in Europe, changing them from Roman numerals because they were obviously a lot easier to use as we still use them today, and he introduced them to Europe. And some Greek buildings use the golden ratio, such as the Parthenon pictured above. It's not known if they were supposed to be built that way or tried to be built that way, but they might just fall into that category. And overall, my reflection, I was interested in the Fibonacci sequence because I've heard of it before in like movies and TV shows, and I just wanted to see how what it actually was. And I was surprised to learn many things. I mean, especially that it can be used in the real world with a growth model. The first one that was actually established with unpredictable shocks. And learning about Fibonacci himself was interesting. How somebody that was born so long ago or did this math so long ago could come up with this complex formula that I'd never be able to think of. And it was also interesting how Fibonacci talked with foreigners when he was at the Mediterranean and kind of conversed with them to see how their mathematics compared to his, and it helped him learn a lot more and helped him establish the sequence and use Arabic numbers. And there's my bibliography for my sources, and that's it.